All right. Okay, thank you so much. Thanks for inviting me and for giving me the chance to present our research. It's about user-driven development in IR. I'm in the project group at my institute where we deal with natural language input for product search, both from the technological side, but also from the user side. So when we started, we thought we should learn from the best, and who is best in understanding natural language? Of course, it's us humans. So this is why we took a user-centered approach to the problem, and I'm very happy to share my insights or some insights with you today. Now, before we start, a quick heads up on the agenda. I'll first quickly introduce you to my personal UX toolbox, so all the methods that I have at hand to develop technology in a user-centered or even user-driven way. To some that may be bone dry theory, but bear with me in part 2 and 3, there will be more hands-on stories. So after the methods, I'll show you how we use them in our project to explore and understand natural language. And then in the end, we'll talk about how to actually build search systems based on those insights. Okay, so let's start with the UX toolbox. Maybe to avoid confusion about terminology, people sometimes talk about UX and usability as if they were interchangeable. But in my understanding, UX design or user experience design is a more broader view on the user. So things like what motivates the user, why is he using a certain technology, how does he use it, how does he perceive it, and also how does the technology change the user's behavior. That's all part of it. And then usability, on the other hand, is more focused on the interface design, in my opinion. So what buttons do we need, which functionality, which colors, how can we reduce click paths, and so on. So usability to me, that is only a small part of UX design, but others might define that differently, but just so you know what I mean when I talk about UX design methods. And what might sound like a nice extra or something that you do in the end if you still got time left in your project is actually quite vital for any technology. So let me give you a few reasons why that is. So first, from a business perspective, the most important reason is simply profit. So if you know your users, you can deliver the services they need, they get happy, they stick with you, and boom, profit. Really comes down to numbers. So say you have an e-commerce setting, you are selling groceries, and you have an average customer loss of 50%. So of all the people using your website, only 50% actually purchase something. Maybe the other ones are just browsing for fun, but maybe it's also because you don't offer credit card payment. And if you know your users and you observe them, then you figure out that it's about the credit card payment. You offer this option and boom, your profit goes up. And then, of course, there are other factors as well, more from, say, the personal side, like it's really stressful to see people struggle. Imagine you observe your users and they are all frustrated. That's not really making your day any better, and it's also not making their day any better, so that's bad. Or imagine spending 2 months on building a feature, being very proud of your work, and then nobody uses it. Also sad. And then also if users feel heard and they feel understood, that might also increase their loyalty, which then again leads to more purchases and more profit. So here is my personal UX toolbox. For each stage in the development process, we have different methods that we can use to get insights and feedback from users. In the beginning, you might want to start by really understanding the problem. So you can do that either by observing how people currently perform a task and also in which context they do it. So say you want to develop a navigation system for blind people. Then start by observing how they navigate at the moment, which tools they use, what problems they encounter, maybe also which workarounds they came up with. And then once you understand their needs, you can design a solution based on that. Then we also have methods where we can design technology together with our users. For example, if you want to build a robot dog and you want to design your robot movements, you can simply hand a puppet to people and ask them to play the robot. And then there you have your robot movements that people also understand. Or say you want to build a chatbot, you can set up some basic guidelines on how your system should work and then let a person impersonate or simulate the system so that you can try out which guidelines work, which ones do not work, and all that without actually implementing the system. And then once you're happy with your design, You can build your solution, test it for usability, or try out some features with A/B testing, just to see which ones work best with your customers or with your users. And then eventually, with your finished system, you can put it in production and monitor how people use it. For example, you can give them a short questionnaire that you can put on websites and ask users whether they would recommend the system to their friends, which then tells you about how satisfied they are. So you see, there are a lot of different methods that we can use at different stages to understand what users need and how we can improve a system. Now, one thing that you should never do is you should never ask users what they want, at least not phrased like that. So there's a very popular quote from Henry Ford, so the inventor of the car, who said that if he would have asked what people wanted, they would have said they need faster horses. Well, I'm not sure whether he actually said that, but it illustrates quite well why we need to be a little sneaky when figuring out what users actually need. I personally always find it very helpful to imagine that my users are like aliens, and I have the opportunity to observe them, just to bring some distance between me and the users, so that I'm more objective. Because I often find myself thinking, oh, I know what they want because they are like me, but most often that's not true. So I try to imagine that I'm researching this new species. Instead of asking them what they need, I ask them what they are doing and why they are doing it. And of course, if I want to learn something about aliens, I have to observe actual aliens and not humans. So make sure that you get the right people to look at. And of course, this is all true for business applications, but also in research, where you might want to make sure that your research eventually addresses the real problems or the problem that you wanted to address. Okay, so in case you're not yet convinced that UX design is not just a nice extra, I have brought some examples. So this is a picture from a bathroom stall. If you look at the lock, try to take a second to guess if the door is locked or not. It's quite hard to say, right? This is something very small, but very impactful. If you apply this to a website, you would want your users to feel safe while using it, right? You do not want them to wonder whether the door is locked or not. You want them to feel confident about their actions. So maybe you add a little indicator that tells them whether the door is locked or not. I brought a second example that actually contains some technology. When I was getting my master's degree, we were asked to build an app to control one of the oldest robots in our robot lab. That's the one on the left side. It can drive around basically like a Roomba. And they wanted to use it to design robot movements in a conference workshop with children. So we designed an app for a tablet like we were asked to, and that's the design on the right. The big blue button functions sort of as a joystick, so you move it upwards and then the robot moves forward and so on. When we tested the app with children, they were all super confused. So they started to look at us with their big eyes and they just stood there and they did not know what to do. And it turned out that they were actually too young for perspective taking. So essentially, they were too young to use a joystick and predict where the robot is going. So that was all super confusing for them. So joystick solution totally did not work for them. And that was a very sad moment. Like, I felt very guilty that I put those children in a situation that made them feel uncomfortable and frustrated. So we thought we need to come up with a different solution, which got us here. So we basically put a shell around the robot with an eye that indicates the direction, and then build a smaller version of the robot that functions as the remote control. We put a lot of sensors in the small one, so it could detect motion, send it to the big one, and the big one would then just imitate everything that the small one did. So the children can manipulate the small one, something that fits in their hand, and then the big one just follows everything. We tried this with different children, worked perfectly. They were all happy and had fun playing around with the robot. And I'm very convinced that if we did not try the app with real children, so with our target group, we would have gone completely wrong on this one. So I hope the value of UX methods is clear to everyone. Those examples are, of course, quite general. So let's see how we can use the UX toolbox in product search. And we might want to start at the beginning of the search. So at the start of a search, we have the user with an information need. So there is a person who wants to search for a product, and this person has some idea about what this product is and how it should be used or what it should be used for. Now, the difficult thing with users is they have to externalize their needs. So they have to use their mental capacity and energy to tell someone or something what they want. Now, some people might be very capable of doing so, but others might not. Maybe because they don't want to sound stupid, because they feel like the other person would not understand, or maybe they simply don't have enough knowledge about the product. So in our research, our first step was to investigate exactly that problem. How do people formulate their information need? And then also, what do they eventually type into the search bar? Because that is an extra step, right? You first have to know what you want, and then you have to formulate it and type it into the search bar. Of course, there was not a random hunch. There's already a body of research on query formulation. And this research points, for example, to the fact that keyword search, which is very often used in search systems, is not the most intuitive way of searching. So there was a research group that asked children to search for something online. And they found that younger children typed in a whole question or a whole sentence. And then older children, on the other hand, they typed in keywords. And the interesting part is they are not very good at choosing keywords. So they were actually less successful with their search. So you might be wondering, why did they start to use keywords then? And the answer is simply their parents. So some parents had taught their children how to use a search engine, and those were the ones using keywords as search terms. Now, of course, with more practice and with more time, they eventually learn how to pick good keywords, but it shows quite clearly that keyword search is a learned behavior and not an intuitive way of searching. Now, why is that a problem? So why do we care about natural language input? If we've all learned how to do it, then that should be fine, right? Well, no, there are two reasons. So first, picking keywords or choosing the right keywords uses energy and mental capacities. So it's simply an investment that we do that we did not have to do if search engines would support natural language queries. And then secondly, with the success of voice assistants, it becomes more important to support voice search, which then again is in natural language and not in keywords. So however, most search engines still rely on keywords as input, but I think it's time that we reduce the cognitive load for users a little bit and build systems that eventually serve the users and not the other way around. Before I go into details, let me quickly tell you about which domains we focused on in our research. We have laptops, we have jackets, we have recipes, and data sets that we investigated. Information needs in those product categories vary a lot in their complexity. So it was quite interesting to see the differences between those domains. Dataset search might stand out a little, but let me assure you, it's a huge use case in the social sciences, and social scientists very regularly search for datasets and also for questionnaires. And since my institute is focused on the social sciences, we also explored that use case. Okay, so let's start by looking at the differences between what people need and what they would tell a search system that they need. Some time ago, we did a user study with around 130 participants. We did not tell them that we did research on search systems just to avoid biasing or priming them. We simply asked them to imagine that their laptop broke down and they should explain to a friend what laptop they would buy as a replacement. They then typed this into an open text field in our survey, so not related to any search engine whatsoever. And then afterwards, once they had typed in what they wanted, we asked them to search for a laptop on Amazon and provide us with the search query and with the URL. I have brought an example here where you can see quite clearly that the user was very well able to give information about what she was looking for, but then she only typed the word laptops into the search bar. Now, funnily enough, the word laptop did not even appear in the natural language description. So you see that there's quite a big difference between those two. Overall, in our study, we found that queries were on average about 90% shorter than the natural language descriptions. I think they were about 3 words long, and the natural language description was about 25 to 30 words long. Queries often described only a single characteristic of their product, while the natural language descriptions contained more attributes or more information. So you can see there's really a huge difference between those two. There's definitely something happening here. Now we only asked for the initial query, so it could be that they used the filters a lot and they changed a lot throughout their search. But it's still quite interesting because it shows that current search systems initially do not get all the information available about the user needs. But if we somehow get the users to type in more information in the search bar, we will possibly also be able to retrieve more relevant results directly in the beginning. Now we also looked at another important factor of natural language, which is vagueness, because vagueness poses definitely a challenge for search systems, right? So you can have vagueness in words because words sometimes have more than one meaning, like the word blue, that's a feeling and also a color. And also the word Mac, which we discovered in our study, is a laptop model, but also a clothing brand. So words can be vague because they have a double meaning or because their meaning is not well defined, like in the words big or nice, or in this example here, we have decent processor. Less than 500 pounds is not as vague, but it still needs to be processed correctly, but we will come to that later. Now, I have the feeling that you guys have encountered similar problems already, so let me show you what we found out about vagueness in information needs. So we asked annotators to assign scores from 1 to 10 to each of the natural language descriptions, basically labeling how vague the description was. And we found that we have very vague descriptions, but also very precise descriptions, but not so much in between. So basically we have those two groups of natural language descriptions. Usually you would expect more of a bell curve, but here, yeah, you have more or less distinct groups. That means that if you do not support vagueness, you are potentially missing out on half of your customer needs. Now we have done exactly the same study with social scientists for dataset search with exactly the same results. So that's also a domain independent problem. Search queries were in general shorter than the natural language descriptions, and they also left out important requirements in the final search query. Then we've also looked at vague words and vague expressions for dataset search. Not surprisingly, our social scientists refrained from using vague language in the actual search queries. So you see users put a lot of mental effort in formulating the search query, just to put it in a format that the search engine can then eventually understand and process. By the way, if I'm not mistaken, you also said that in the beginning you focus on voice interactions. And in voice interaction, you might have additional challenges that further increase vagueness. I know that another research group has previously compared written and spoken queries. Maybe you know that already. They found that people try to avoid words that are difficult or tedious to pronounce, for example, big numbers. So users might use words like, I want recent data sets or new data sets or a new laptop, instead of saying, I want something released after 2020. So you get more vague information, even though the users would in fact be able to be more precise. Okay, so summing up, we have learned two important things about user information needs in product search. I want to be very clear, I'm not saying that search engines that exist today are particularly bad, but I think our findings show that we could do more to support the users and make it easier for them, and maybe leave them with a better feeling and feeling more confident about what they found, and that they found exactly what they were looking for. So we found that users withhold information even though they could explain more about the information need, and they are looking or searching in a vague way. So after finding out about this, we thought, okay, we need to take a step back and look into human-human conversations for more insights. So our goal was to figure out how experts help other people during search. We found some recipe experts, we found some laptop experts with experience in consulting people about recipes and laptops. And we simply observed them during their consultation sessions. Well, we had to do it online because of COVID, but it was kind of like an in-store situation where you just walk up to a salesperson and you simply tell them what you want and they ask questions back and eventually find you a suitable product. So we told our experts that they should find a suitable product and put a link to that product in the chat so that the customer can then open it. And yeah, we told them that the session is over once the customer is happy with the product. This eventually led to conversations where they first talked about the need of the customer, then the expert sent the link, and then they often continued the conversation by talking about the specific product. And then when analyzing those conversations, we found several strategies that we think could be helpful for search systems. First, in the first part of the conversation, the experts were very proactive. So current systems, they are quite passive. So they just wait for the user to send in a query or change the filters. So there's definitely room for improvement here. Then secondly, experts were very good at asking questions in the beginning. They often started with very general questions that anyone can answer, like what do you use your laptop for? Or what type of recipe do you want? And then later on, the questions were more precise and more adapted to what the person said before. So if someone was a software engineer, they later asked more technical questions. If someone was a student, they just asked about portability, for example. And then the experts often back-channeled whether they think they understood the customer. So when someone was telling them about their needs, they often said, okay, I got it, or made sounds that well, indicate agreement, like, mm-hmm. And this is especially important when there's a difference in knowledge, because the customer might be unsure whether they use the correct terms, kind of like they are unsure whether they closed the bathroom stall or not. So they want to know whether it makes sense what they say, or at least the expert thought so, so they had to react to that. Then we also saw a lot of instances where people said that, well, what they were up to. So the expert said, oh, wait a second, I look for a laptop now. Or the customer said, let me think for a moment, or I'm reading the description, give me a minute. So they disclose their inner state to the other one. So both can plan on the next steps in the conversation. Then after receiving the product link from the expert, the conversation was still not over. We were actually quite surprised to see that the conversations went on after that. But we were also surprised to see that the roles change. So once the customer got the link, they started asking questions about the product and they were more proactive and they wanted to know why this product was a good fit for them. So instead of the expert being the proactive part, like in the beginning, now it's the customer taking the proactive role. And then finally, after the conversations, the laptop experts told us that they have sort of a blueprint of a laptop that they sell. So I think it was a 500 euros machine with 500 gigabytes of memory, maybe 4 gigabytes of RAM or something like that. I personally found that very interesting because usually search systems just take the input they get and then return matching results. But the experts implicitly added those standard information, unless, of course, the customer wanted something different. And I think this implicitly increased the precision. Okay, all in all, after this study, I had the feeling that there's so much more we can do to provide better support for customers and to make it a more intuitive and a more holistic experience. But before going on to designing a new system, we went to check on existing systems just to see how well they already match the information needs of users. We did this with jackets and laptops, where we found that the filters that Amazon provides only match 18% of the information that users described in natural language. So we thought maybe this is because Amazon is not specialized on those products. So we went to check on specialized retailers. But it turns out that even those specialized retailers only match about 1/3 of the natural language information. Information that did not exist as filters, for example, the purpose of a laptop, the season of a jacket, so is it a winter jacket or is it a summer jacket, or things like the reputation of the brand. We did a very similar study also in the social sciences for dataset search. We asked around 70 social scientists to tell us what they need, and then we took 30 existing search engines, extracted all the filters, and then checked how many filters matched information that we saw in the natural language descriptions. Here it was a little better, so we had about 50% of the filters that were useful, but this also means that 50% of the filters were not useful. So maybe I should show you the filters of the specialized laptop retailer. This looks quite overwhelming, right? And they still have 10 times more filters than what is shown here. Yet still, a lot of the natural language needs were not met. So the purpose of the laptop is not in those filters. So in the study with the social scientists, we also explored how the search bars made use or made sense of the queries. And for all 30 systems, we used queries that contain meta information. Say someone was looking for data on democracy in Europe, then a system should be able to see that democracy is the topic of the data set, and we have a geographic constraint in Europe. Only one system out of the 30 was able to do that, so to explicitly match it onto their filters. That's not only a problem in dataset search. I can show you with some examples what I mean. So here we have Amazon. I was asking the system for jackets of the brand Marmot. It did retrieve jackets from Marmot, but why is there an unchecked box about which brand I want? I already said what I want. Funnily enough, if I tick this box, then the results change. Now, you and me, we might have an intuition about why this is, but the average customer might not. So this probably does not make sense to them. Then here we have Best Buy, a retailer for electronics. I was asking for a 17 inches MacBook, and the system gives me a filter for notebooks of 15 and 16 inches size. I don't know how you feel, but as a customer, I would be completely confused about this. Okay, so let me sum up what we have learned from analyzing user needs and from the human-human settings. So we know that the users adapt their search query to what they believe the system can handle, which is why they withhold information. Some parts of the information needs are vague, so we need to account for that as well. And existing systems do not really support users in a way that is intuitive for them. So they need to know what the system is doing, why it is doing that, and in order to do so, we need better data so that we can eventually provide the support. So the question really is, how do we get there? And this brings us to the last part on how to eventually build more intuitive product search systems. Now, for this part, I'm just going to throw some ideas around. So spoiler alert, I don't have the perfect solution that fixes all those problems, but we can at least make some educated guesses what might work and what might not work from a user's perspective. Okay, so step one is a very basic one. You need a system that is able to process natural language. That includes basic things like extracting the important phrases from a whole sentence, understanding synonyms, understanding negations, understand what we call modifiers, so words like probably, maybe, or preferably, that would tell you that it's not a must-have, but a nice-to-have, and stuff like that. We have actually collected and annotated a whole corpus of natural language queries for laptops and for jackets, which I believe is around 3,000 queries big. So we have annotated about half of them, all the laptop descriptions with important phrases. We have annotated negation terms, modifiers, and we have also mapped each important phrase to a product attribute. And this is all to train machine learning systems. And so far we have achieved quite good results. For example, for predicting the important phrases. So what is here in the descriptions, the MacBook Air, slim or easy to use. For that, we have a named entity recognition model that runs at 92% accuracy with the bio scheme, which I think is pretty good at a level where we can use it in our prototype. We have made some small retrieval tests on a very small data set with relevance scores of 50 laptops. We had to make this data set ourselves, so it's not very reliable, but it at least can show you some tendencies. And we can see that just the step of extracting important phrases already makes a huge difference in retrieval performance. Maybe at this point, let me make a small side note on evaluation in machine learning systems. I think it's quite important to keep in mind that the performance numbers that we usually compute to evaluate our systems, like accuracy, like precision, or the F1 score, they are all treating all mistakes equally. And then people think, okay, I got 90% accuracy, that's good, so my users will like it as well, and they will use the system. But that is not always the case. We have done a study where we asked people to judge on classifier output in a binary classification task. It was a text classification, so they had texts, and they were told that the system decides whether this text is about a jacket or a laptop. Well, it was quite handy. We could just use the data set that we had already collected for that. And we really knew what the ground truth was like. So we knew whether it was talking about a jacket or a laptop. Might be useful, for example, if you want to detect the product category in a search query or in voice search, for example. So we gave them easy texts and also difficult ones, and we told them what the system predicted. And then we asked them to indicate whether this prediction is correct or not. And funnily enough, people often just agreed with the system. So when it was a difficult text, for example, I want something cheap and not too bulky, it's quite hard to say whether it's talking about a laptop or a jacket. It could simply be both. When we did not show the prediction of the system, 50% decided for a jacket and 50% decided for the laptop. But once we showed the prediction, then roughly 70% said that it's indeed a laptop. So you see, it really drives up, or it really changes what people think about a text. Now, I'm telling you this because I want to emphasize two things. So first, users do not have binary opinions. It could be that your system has a low performance, but because your data is very difficult to classify, users actually think it's fine. Or the other way around, if a system makes mistakes on very easy data, it might be that your users are repelled and completely stop using the system simply because it's obviously bad. Even if it's just in a few cases, those obvious mistakes could lead to, well, could impact your users strongly. And then secondly, users do not actually judge whether something is correct, but whether something seems correct. We usually also ask people when we do this research on how AI decisions are perceived by users, we ask them why they think the system makes mistakes. And they often say things like, it seems to be correct, or it seems to be wrong in this one. So for them, it's about judging how plausible an outcome seems and not whether it is actually correct. So when we build the models that predict, for example, important phrases in natural language queries, we focused on a plausible output and not on high performance per se. Of course, it also has to be high performance, but it also needs to make sense to the user. And I think that's a good compromise. So automatic systems will never be perfect. They will not always understand the user, but we can at least try to choose the system where a user would say, okay, I did not understand, it did not understand the last part, but that was not too important anyways. So always check in with your users. Always look at the data yourself. Does it make sense to you? What mistakes does it make? Do users eventually recognize them as mistakes, or is it actually fine even though the performance is not perfect? So once you have a system that can process those natural language inputs, you will need to make sense of the individual phrases and resolve the vagueness in there. For that, we need two things. First, we need to enrich our data set with natural language fields so that we have something to search in, right? So each product attribute for each data field, you will need a second data field with the same information in natural language. So say you have a 13 inches display, you need another field that says small display. If you have an i7 chip, you need another field that says fast processor, and so on. So how do we know whether something is perceived to be big or small? Well, we simply ask our users. Maybe not the ones that do not have knowledge about laptops, but maybe the ones with medium knowledge, so that should be the biggest chunk of your users. We found two ways of asking them, for asking users about this. You can either ask them which laptop they have, and then ask them to say, for example, whether they think their laptop is big or small, or you ask them in general which display size they would still consider to be small, and so on. I personally think the first way is better because they have a good reference of something they already know. So they are well capable of assessing whether it's big or small. We also tried to extract those information from customer reviews, but we failed miserably simply because there's no clear cutoff value. So for example, for price, we found that anything below 1,500 euros was considered to be cheap, but then also anything above 500 euros was expensive. So the ranges really overlapped so much in our data that we did not feel comfortable using that as the basis for our decisions, and we went on to ask our users. Another thing that we tried is that we enriched our data set with other information that users usually look for. So for example, for laptops, we added things like the purpose of the laptop. What can it be used for? Like, is it a gaming laptop or is it a simple laptop, and so on. For data sets, we added fields that describe, for example, the topic of a data set, which is an information that wasn't there before, but people simply look for topics, so now they can find it. You can do this with annotations and with machine learning, or you can also do it with rule-based systems. So if you know which factors contribute to a laptop being a gaming laptop, then you can simply set up a rule-based system and enrich your data with that information. So all in all, there are many ways to enrich your data set so that in the end it contains all the information that you need on the front end side. Okay, after that, so after we have enriched our data set with vague information about the product, we need to make sure that we are searching for matches in the correct data fields. So for each phrase in the search query, we need to figure out what is it talking about so that we can look in the correct fields. You can use annotations of product attributes for that, train a model on predicting the attribute field, and then only search in those fields. Obvious disadvantage of this approach is, of course, that you need a lot of annotations and you need a taxonomy for every product category. So you need a taxonomy of attributes for laptops and another one for jackets and so on. Maybe you can also use unsupervised approaches, but so far we did not really have luck with that. The performance of clustering algorithms was not very good at that task, at least. I don't know, maybe there are other ways of dealing with that, maybe more natural language approaches, like you use proximity search with the whole phrase, but I don't really have a good solution for that yet. But for now, let's assume that we have already found a way to overcome this problem and we have a system that can understand natural language queries. At this point, our system is comparable with existing systems. The only thing we have to change is that it works with natural, or the only thing that we have changed is that it works with natural language instead of using keywords. But we still have to deal with users who have learned that they should use keywords and who withhold information because they think the system cannot handle it. So we need an interface that can communicate to the user, hey, I can deal with natural language, just speak your mind. So we have designed 4 interfaces that you can see here, of course, based on literature that tells us about search bar design and so on. And we have compared what users type into those input boxes. We looked at the length, the amount of information, and also the vague language. And you might not be surprised that the chatbot interface, so the one at the bottom, triggered users to write more natural language, and also to disclose more information about the information need. So our problem that I told you about a couple of slides ago, that people withhold information, can actually be counterbalanced with the graphical design of the interface. We did not have an interaction in the study, so the chatbot did not answer anything. It was really just about the design. Which then made us think, together with what we know about human-human support in product search, we can maybe still do better. But for that, we need a dialogue between users and system. We need a system that somehow looks or acts like a chatbot so that users feel comfortable to just speak their minds. We need a system that guides the user throughout the search process, very much like our experts did. So this brought up 3 design ideas. First, the system should be proactive and ask questions about the user needs. That can be in form of a chatbot or maybe an interface that is less Amazon-like. So, you know, interfaces with search bar on top, filters on the left, and then results in the middle. Maybe we need sort of a Google-like interface where you enter the store and you only have one question. What do you want to use your laptop for? And then a simple single answer field. And then after answering, you get a second question and a third one. And maybe if you choose those questions wisely, that is already enough to retrieve appropriate products. Or maybe you just have an input field asking the users to describe the laptop they want. And if the system detects vague conditions, then it simply asks the user, hey, how do you define a big screen? Maybe you can also give advice, like most people think that a big screen is anything larger than 17 inches. Is that what you think as well? We have made a prototype of such a system. Let me bring it up. So it was really just a prototype, but it detected important phrases. It displayed them to the user. And if anything was unclear, it was highlighted in yellow, and the virtual assistant would then ask questions about it. Now, the nice part here is that you do not even have to resolve the vague expressions yourself. The user does it for you, but in a very guided way. We made some usability tests with a very small amount of people, but they all seem to enjoy the system as it is at the moment. We still have to make a structured user study to evaluate whether it actually improves the results that we get. Another design idea for a dialogue system is that you can tackle the part where you present the results. So instead of just saying, here are the results, now go figure it out yourself, the system could explain how the results fit the user need. So you remember I said we were surprised that the human-human conversations did not stop after the expert sent the product link, right? So if you have a dialogue system, you can explain and present the result to the user in a way that users can understand, namely in natural language. So there's this whole field on explainable AI and a smaller field of explainable IR, which could be very useful here. The user then has the opportunity to also ask questions, which could be a nice feature as well. And then finally, the third design idea is having a dialogue system that allows you to tell the user what the system actually understood and which parts it did not understand. Kind of like in our prototype where you can see which phrase the system uses for sending a request to Elasticsearch. It could be that the system says something like, all right, I think you want a big screen, just to tell the user that this part was understood and is taken into account for the results. There's this field of conversational search where a lot of research is already done on dialogue system. Not so much on product search though, but I think together with what we have discovered in our user studies, we now have quite a clear understanding of how we can support the users in product search. It maybe does not have to be a perfect dialogue system. Maybe as a first step, we try small elements like maybe how we present the filters, how filters are formulated and so on. So maybe a first step is to offer vague values and filters like small screen, medium screen, big screen, instead of displaying all the numbers, or present filters sequentially rather than all at once, or maybe build a chatbot or include some dialogue elements on the interface. in any case, a lot can still be done. So it is clear that we need help from machine learning and from NLP methods to get there. And I'm very curious to see what online stores we will have in the future. And that's about it. Thank you so much for listening. And I'm very curious to hear your opinion and what you have already tried in that area.
Okay, yeah. Thank you very much, Andrea. I guess you won't be reading this now.
I won't. No, it's just there, okay. So that you know where I got this information from.
Well, yeah, that certainly rings many bells, what you just said, and I think we'll have comments on various aspects, and we're happy to share how we sort of think about some of these things. I can see that there are two specific questions in the Q&A section there. I don't know if you can see that. Or I can just...
I can see, yeah. Yep. So the first question was, what kind of negations do users use when searching? Could you provide some examples? And does your model handle those negations? Yes, so negations can be things like, I do not want an apple because I have made bad experiences with them. Or it can be things like, I think never is also something they use, or isn't, or yeah, all those terms. We actually just have a dictionary list for that we retrieved from our data set of the natural language queries. This data set is online. Unfortunately, in the first version, we did not have the negations and modifiers yet, but there will be a version number 2 coming out soon, so where we have those annotations as well. We also did train a model to understand those negations, but I think because it's a very small list of signifiers for negations, you can just use it as a dictionary approach and then use that to modify your Elasticsearch query and just say this should not be in the results. I hope this answers the question sufficiently. Let me go on to the next one. It says, as you mentioned, users want to know why something is a good fit. Have you tried or have you any experience in addressing this issue in any way? Some explainable AI methods or something different? Yes, so I think, so I've done a little work on explainable AI, but more on how users perceive what is told. And we actually, funnily, we found that explaining is not always increasing user trust. So if you give them an explanation that is based on statistical evidence, so basically what a machine learning model uses, then it might lead to your users not understanding them and wondering why this is a good explanation, and then lose trust in the system. So you really have to make sure that it's an explanation that people understand. This part we haven't tried yet, so I cannot tell you what are the explanations that work well for users. But from what I've seen in the human-human conversations, it is usually referring to their information needs. So saying, I know you want something with a big screen. Here we have a laptop with 19 inches display. This is usually considered a big screen, so this addresses your information need. So that would be my suggestion to, to just check with the information need from the beginning. Okay, oh, there are more questions popping up. That's nice.
You have to keep up.
Yeah, I have to talk faster. No. So next question is, did you notice any patterns or segments between users who interact with chatbots? So are there, for example, differences between millennials and older users? Do they ask questions or interact with the chatbot interface in different ways? So the usability study that we did with our chatbot, we actually excluded people older than 40. So we said we only want to have digital natives in our as our target group. But I agree that would be very, very interesting to see. So I actually found out a while ago that my mother got a smartphone and she uses voice search. So that is something where I personally thought this is something that younger people use because they are more, they have more this affinity to technology. But for my mother, apparently it was something so easy to use that she went for that instead of like opening the browser and Googling for something. So I agree that would definitely be something very interesting to see. I unfortunately don't have any insights into that yet. Okay, then fourth question. How did you extract filters from the store? Manually, was it some sort of automated process? So for the first study that we did with laptops and jackets, we only had 3 stores that we looked at. So Amazon as like the general retailer, and then Skinflint for the laptops, and Next for the clothes domain, because they were, well, it was all in English, so we had to take English retailers, and we did do that manually. And then we, we checked, we simply checked with a string match whether it matches or not. So yeah, it was semi-automated. So we extracted it manually, but then checked automatically. And for the data set search use case, we extracted them all manually, and then also checked on more on a conceptual level. Does it fit or does it not fit? Because we really wanted to know, does it not mention the information in a way how the users formulate them, or do they simply not have the information? So things like, if you want a data set of a target group, for example, of older people or from younger people, then if you would just look with string matching, whether the information is there, then you won't find anything. But it was there, just in a different form. So they had things like, well, actually, no, that's not true. For the target group, they didn't have the information. That was for some other filters where they, yeah, I think the release date was the best example, and maybe also the geographic area. So people were looking for things in Europe or in the EU or in African countries or the Middle East. I think that was something that someone said. But then the data sets only had information about exact countries. So the country codes were connected to the data set. So the information was there, but not in the right format. So for this study, we did do it more on a conceptual and on a manual level. And yes, there was a lot of work. So yeah, it's good to understand, but it's not something automatic.
Sure. I think we went through the list. No, one more.
What do you think the future holds? Oh, well, that's a very broad question. Will keyword search be a thing of the past? Well, I hope it is. So at least on the front end side, I think we cannot go around keyword search on the back end side, but I think this is a thing that we should solve with technology, and this isn't something that we can outsource to our users, or that we should outsource to our users, because it will lead to confusion, because it will lead to more mental load. And it will also lead to people not being sure whether this is actually what the system understands. So maybe we can take on this task and leave the natural language then to the users and having nice, easy, intuitive systems. Okay, I don't see more questions.
More. So yeah, there are quite a few things that sort of went through my mind when we were talking about that. That certainly resonate with our experience, people we talked to. So for instance, you mentioned that people withhold information, and that is certainly something that we came across as well. And sort of the way we view that is that there are 2 problems here. One is this, you mentioned this energy conservation, right? That you don't want to basically do something unless this is really necessary. Mm-hmm. And typing, especially on mobile phones, not so hot. So that's one thing. And the other thing is that we quite often heard that they actually do not believe that if they type something more in the in the search bar, that they will actually get better results. So that's why, and we were actually thinking about it from the UX perspective, how to actually convince people, you know, maybe when this is working well enough, it will sort of naturally, catch on. But so that's one way issue. And the diagram that you showed about vagueness of queries, right? That there is this sort of B-model distribution. So that sort of maps onto sort of two patterns that we found, at least two patterns. One is this broad type of queries where people do not actually themselves really know what they're looking for, or I'm just looking for a gift, whatever, versus this, okay, I know exactly or almost exactly what I want. Maybe I'm just checking the price. And we're sort of thinking maybe that these two are different enough that they should be handled completely differently.
Yeah.
That the traditional search engines seem to have sort of a few tricks, know a few tricks already, like Etsy, for instance. When you type something, it checks how many categories it maps onto, and depending on that distribution, they sort of guess whether you're in this broad mode, and they should show you different categories just to maybe narrow that down, or go straight to the category. And so that is, I'm not sure if there are only two modes like that, but certainly those two are there, even from just talking to people.
Yeah, I definitely agree. Especially for the vague one, I think there are more distinct cases. So either people do not know or they do not care. But I think there are also people, when they say they want, for example, a fast laptop, then they don't care how this fast is achieved. They just want a fast laptop. So that is why they don't put more details in there. And usually our experts were able to map this sort of onto the technical details. And the users do not have to do this. They simply want a fast laptop, and that's way faster to type or to say than to say, I want this RAM, I want this processor with that clock. That's, and I also don't see why users should be doing that, because we are perfectly capable of resolving this. We just need to put a little bit more effort in that. Yeah.
I guess one way to look at that, this broad type of query searching, is also that it's like people use it as a way to learn, basically. What's there. If I don't know something, I'm using actually search to figure out, hey, these are my options, and so on. So that's something that is on our mind as well. And you mentioned this Wizard of Oz approach, that is sort of something that we're thinking about as well. And I was wondering about one thing. What, in your opinion, the wizard, the expert, should have access to when he or she is pretending to be the AI? Is it like some sort of special interface that she should have, like a special search type, or is it just the knowledge that she has? How would you?
Definitely the knowledge. So you're talking about a voice search setting, or?
Well, I guess so. One we're trying to stage the experiment where we built some sort of UI. On one hand, we have user. She would be aware of the fact that she's taking part in experiment there. On the other hand, we would have an expert, like in your setting. Our worry is, though, that if we sort of leave this unconstrained, okay, we will learn something that we will not be able to translate into the system
later. Well, usually for Wizard of Oz experiments, you have some guidelines, and the expert is there to just work among those guidelines. So there's really no room for personal decisions. It's really just the execution that they take over, usually. I know that some more exploratory studies, they don't have that, especially with voice search. So when they are, for example, for recipes, when they have to help someone cook something, so they are there for the whole process, then it's less constrained than if you just want to have a question answering system, for example. So I think you definitely have to set up some rules and some guidelines upfront what the system can do or should be able to do, so the wizard system. and what it cannot. And in case someone is asking for something that the system cannot do, you also have to have the default answer for that. Yeah, because otherwise it becomes too human-like, and then you won't be able to implement it, and you won't be able to pinpoint what exactly you have to implement later on.
Yeah,
true.
I imagine that in your setting, when you were observing those experts, you let them do whatever they want. Yeah,
exactly. We did, because we were simply interested in the the conversational structures. So not really, they weren't there to simulate a system. We just wanted to know how do they support the users during the conversation. Yeah.
And that idea of expert standard and this blueprint that they have in mind, would you mind going through that again? That seemed interesting to me.
Yeah, so basically that was something that the experts told us, and that we also discovered later on when we were building the relevance data set. So we had this one student sitting there and mapping all the information needs and all the queries to laptops in our data set. And he was like, well, I don't think that they want a 3,000 euro laptop if they just want something simple, but they don't tell me which price they want. So he kind of assumed that they only want something very standard, and he added that to his relevance score. And I think that's something that the system should do as well, because otherwise you will get results like a 3,000 euro laptop, because it will match all the other criteria that were specified. So it might be a good idea to have something like that, maybe also a little bit more distinct or nuanced. So if someone says, I want a gaming laptop, then maybe the standard for the price is a little different than if someone just wants something for, I don't know, for normal document stuff and a basic laptop.
Sure.
And that's something you can very easily add to the to Elasticsearch queries, for example. So it's easy to implement.
I wonder if there's a problem of sort of contradicting requirements here as well. And the expert is sort of trying to reconcile them.
Yeah, well, they definitely did. So if someone was like, I want a 500 euro laptops, but I want it to be big and very light, and they were like, no, this won't happen. But that's the part where the explanation comes in. So you can offer both to the user. So either something that is not very light, but not too expensive, or something that is expensive and light, and then say, here, these requirements are met with this one, and for the other one, other requirements are met. So really, it's about explanation, and that's also what the experts did.
And finally, your slides about this faceted search, right? The groups, the fact that those facets do not really match the needs of the user. So I wonder. Later on, you mentioned that one of the solutions would be to add more meta information, so essentially more attributes, right, on the products, so that they could possibly match. So we sort of so one thing we are doing is we are using machine learning to go through the product description and try to figure out what the attributes are from there, and we were able to pick up quite a lot of things. But the immediate sort of question was, right, okay, so we know all those details, but do users care actually? Is the right information in there? And that is, I guess, not something you can solve just using technology. You could you probably need somebody from the business to supply you with that information. I'm not talking about synonyms. It's just the facts, right?
Yeah, true. So we figured that users very often describe things like experience attributes. So how long does a laptop actually last? And that's, of course, if you ask the retailers, they will all say they last for a very long time. And they will all say, oh, our computer is very easy to use. So you really need other people to comment on that. And then you have the problem that for new computers, you don't have this knowledge. So it's really difficult to get all the information that users want. I don't really have a good solution for that. We also had some laptops where we simply don't have information on the color, for example. but we have the picture. So maybe, maybe you could do something with that. But I agree. So you need at least some information about the product to then derive other attributes from there, and also make it more natural language, definitely.
One phrase that quite often shows up in the search industry is the fact that search is a team sport. You can't just have technology team there. You need to have a business team as well, content curators, marketing, sales, and so on. So maybe okay.
I think you have to, you call it a team, so that's maybe the important point. So you cannot just have people saying, okay, this laptop has this processor and so on. You really need to work together to get the right information and to phrase it correctly, because the retailers, they have so much knowledge about their product, and they will use technical terms and they will be very precise, but that's not always what users want and what they're looking for.
Yeah, absolutely. All right.
I have one comment. So there are two sides of the problem, as far as I understood. One is the natural language part, and the other is sort of product part. How do you structure products in the store? How do you figure out which are good gaming laptops, for example? So would you agree that this second part it's very much domain dependent? So it will be completely different for laptops and jackets, I guess.
I agree. And as I said, we also tried with clustering and unsupervised methods so that we make it a little bit more domain independent, but the results were not very good yet. My feeling is that there will be some use cases and some parts that you can solve domain independently, but maybe some others might not. And also, so we've tried to also make or retrieve different senses from the phrases. For example, if there's a number in there, then very obviously it should be matched to numerical fields. And you can already leave out all the rest, which might give you some noise, stuff like that. That's also domain independent, and you don't need extra knowledge to do that. But I think it works hand in hand, those two solutions.
Okay. I wonder if there is a sweet spot where you do some manual work in a given domain, but it's not that you make a separate solution for every store.
Yeah. Well, once you found that sweet spot, let me know.
We will.
I was also sort of wondering, so we were talking about voice input, right? How it may change things. So first of all, it's easier to say the whole thing rather than just type it. And the other thing is that I wonder, what are your views on that? Sort of from the psychological point of view, when you know that you're talking to a machine, maybe you are sort of more open to experiment and ask different, various questions that you wouldn't necessarily ask human, because you don't want to be judged. Hey, I'm stupid. Well, you mentioned that. So maybe we will see sort of even different patterns there.
Could be. I think you need to find the right people for that. Because I think even in that study that we did with just the interfaces, we saw this very strong impact from while they have learned they need to use keywords. So you really need to put them in a context and in a situation or scenario where they feel comfortable to ask those questions to the machine.
All right, so we don't have any more questions here. We're 10 past our allotted time, so it's a good sign. The conversation went well. Andrea, thank you very much for your presentation. I loved your drawings there.
Thank you so much for having me and for letting me.
And we will have recording of that. We will send it out. Okay, thank you very much.
Thank you so much.
Bye-bye.
Bye.